right, guys, welcome back. We're going to talk about transportation, which is a super interesting topic. It might not sound super exciting, but it is basically the reason we take up as much space in North America. And without transportation, there's a lot of things that don't happen to America to make it a great country. So, yeah, we're going to talk about this, and this kind of feeds off of what we were talking about in the last section with Henry Clay's American System and Transportation. So, our big section focus question here is how do transportation's developments and industrialization affect the nation's economy? I think if you just sit and brainstorm for a second and look at this steamship, you can probably think, well, I can get goods from point A to point B a little quicker if I have better transportation. And certainly that's what we're going to see here. So I'll go more into specifics. So, a couple terms here to be familiar with. Turnpike. This is a type of highway, usually involving a toll. It's a term that we don't use in the South much, but if you go up north in New Jersey, you'll see that term turnpike. National Road, we've talked about a little bit briefly with the American System. Erie Canal is a new term for us. The Industrial Revolution, you should know from world history. And then a couple people here, Samuel Slater and Francis Cabot Lowell, and also the Lowell Girl. We're going to look at those documents a little bit more specifically about the conditions of Lowell girls and what their lives would have looked like. Interchangeable parts, small little details, but they make a huge difference. And Eli Whitney and Samuel Morse, two other innovators. So, this is a document. I'm not going to read this, and you guys are going to see with this section that we actually look at some Lowell Girls documents more specifically. So, not going to read that one, and we'll actually do more documents in that. As I've already mentioned, transportation is a big deal because we need to get goods sold. Certainly, the South is producing lots of raw materials. They need to sell those goods because if they just sit on those raw materials, either the price of an individual good is going to drop radically. That's a supply and demand concept. Or in the case of like physical, maybe like more edible crops, if you don't sell them, then they go bad. So, super important to get those crops out. Big thing was to improve roads here. Okay, primary source of transportation in this time is still going to be roads. We're shifting away from that though with canals, and eventually with the Industrial Revolution, we're going to shift towards railroads, which as we progress through the 1800s get increasingly more successful. Of course, success is a double-edged sword. Railroad companies will be able to help bigger businesses transport goods across the United States. We'll have a transcontinental railroad built as well. But also, as we're going to see towards more about in Unit 3 and Unit 4, railroads become quickly the enemy of farmers because they both want flat land to both harvest crops on and build railroads on. And the railroad companies are going to win that battle because of the money they have built up. So tolls or turnpikes, as I mentioned earlier, you can see this little picture here, prevented commerce from being quick and cheap. If you can imagine somebody who is producing a product, taking it from North Carolina up to Pennsylvania, if they had to cross through toll roads, what they're going to do is pay the tolls, but then add the cost of the tolls onto the price of the goods. And so when they get to the place that they're selling, or they get to the person who's ordered whatever crops or whatever substances or whatever they ordered, they're going to end up paying more for it because of these tolls. Okay. To take the side of the toll road person, many of these toll roads had, improved roads. It was more than just dirt, more than just straw or gravel. And so the money that the toll road owners are collecting is in theory going to investment in making better roads. Sometimes that was not the case. So in any case, the fees are prohibitive. They make trade less successful. And what you're going to see with innovations is when something becomes inefficient, such as transportation through toll roads, there's very often going to be a counter solution or some other innovation that kind of comes in to disrupt that market or replace the concept of toll roads. In this case, we're going to see the National Road, also known as the Cumberland Road, and it's a government produced road. So it's a network of roads that would go from Maryland to the Ohio River Valley, which is today West Virginia. It's made of crushed rock, so nothing super fancy or complicated, but certainly more reliable than a lot of dirt roads that would be in North Carolina and other places. You can see the little GIF I have going on here, Steamboat Willie. This cartoon, just for reference, is going to be way later, somewhere around the 1910s, 1920s. I don't know the year exactly on that, maybe 1922, I want to say. But in any case, steamboats became a huge mover of goods once they finally kind of took off. This guy here pictured in the black jacket, Robert Fulton, is the first guy to produce successfully a steamship. So that's his claim to fame. Um, just for some context here, from New Orleans to Louisville took about 4 months. With the steamship, that same trip takes about 20 days. So you're speeding up the moving of goods and transportation of people as well. Certainly, people can travel a lot quicker. So, um, another thing as well is traveling upriver. So if you're traveling upriver, you're against the current. People actually like this little barge down here, these people standing on it with the giant sticks. That's what it used to take. And a lot of times people would have like people on the land that would like pull the ship or have a cart with a oxen like pulling something across the river. Just very inefficient to what we typically think of when we look at these steamships. So yeah, so the Mississippi becomes now a huge, basically, highway for goods and services. Um, Next major innovation here is canals. Just to show you how quickly this takes off and the explosion of canals is by 1816, there's 100 miles of canals. By 1840, that same canals are now about 3,300 miles worth of canals. As I mentioned in the last section, a lot of these internal improvements, these infrastructure programs, benefited the Northeast. And so you can see that again, like the canals are not really kind of flowing throughout the South. And this is going to be a huge thing. Like when we get from canals and we eventually get to railroads, like industry is kind of happening in the North and it's a lot less likely happening in the South. Part of that is because of slavery. Slavery, was an economic boom for people that owned slaves, but it wasn't really forcing people to innovate. It was, basically saying we're going to keep producing crops using the same type of labor we've had for going back to 1619 at this point. Meanwhile, people in the North are trying to sell goods to as many people as possible, right? The South is more just trying to produce as many goods as possible, not necessarily try and get their goods out as quick as possible. So, yeah, so the Erie Canal is a big deal. The big thing here is the population of New York City surged. It also kind of creates like cities like Buffalo and other kinds of cities in New York State. And the Great Lakes become more of an area that people travel to. So, this is the Erie Canal. And you can see again, like these are the people that are either pulling barges or pulling supplies along the Erie Canal as it's being built. Railroads are a very big deal as well. So those will be replacing canals in some ways. Certainly, you see this transformation happen in the UK, in Great Britain. There's a lot of canals being built. And then, kind of in the next 10, 20 years, railroads really take over. So, that's going to be a big change as well. Um, Railroads cost less to build. Obviously, putting a lot of water into a place is a lot more difficult than putting a track on top of ground. And also, railroads, like this is kind of something that blew my mind once I first read about, but railroads were like actually existed before engines did. What would happen though is you'd have the two rails similar to what you're seeing in a regular railroad, and then a horse would pull a cart along those rails. So that was the original railroad, which is certainly still more efficient than a horse pulling something through like a muddy path or a road that hasn't really been paved in any kind of sense. So yeah, what we can see here is railroads in 1850 in pink and railroads between 1850 and 1860 in purple. So you can see that kind of explosion of railroads. Big deal with this is actually these railroads in purple are going to be the ones that are around right at this time of the Civil War. So when we look at the Civil War in Unit 3, we're going to kind of get into this topic of like what are the advantages of the North and what are the advantages of the South. You can already see here the North has so many more railroads. And if you're thinking about fighting a war, railroads are, yeah, a point that could be targeted for the for one side to attack, but realistically, they're more likely going to benefit the side that has the railroads because those are the transportation of goods, guns, bullets, uniforms, food, any other kind of supplies. You're able to get that stuff around the country a lot quicker. For some context here, again, travel from New York City to Detroit, Michigan by boat took about a month. By train took 2 days. That's a huge difference. And so we're going to see this kind of take off. The Industrial Revolution is, this concept that we go from basically everyone producing all the stuff they need to now factories and industry producing the stuff they need. So a lot of those homespun hobbies or homespun crafts become replaced with things like these mills. So this guy here, Samuel Slater, creates a mill, and yeah, that this textile mill concept is going to find its way into America. One of the big examples is the Lowell Mills. We skipped over this essay or this letter from Mary Paul, but we're going to get to that here in a second. Mill workers very often lived right next to the mills they worked in, which sure sounds convenient, but if you think about how long they're working, they're basically working 16-hour, 14-hour, 12-hour days and then clocking out and walking 10 feet to where they sleep. So that kind of like work-life balance doesn't really exist in this time period. The Lowell Mills are named after Francis Cabot Lowell, and they're kind of crisscrossing Massachusetts. So these Lowell girls were women that worked in these factories. You might say, well, like, why did these women work in the factories? Well, the way it typically worked was these women would work, the money they would earn would go back to their families, and then at a certain point, the women would be of age to marry. And so that's when they would leave the mill and go and live with their husband. And, they were expected to kind of do traditional women roles for that time, which is cooking, cleaning, raising children. Um, and that money that the family earned from the woman would also typically go as a dowry to the family, the husband's family. So not a glamorous life at all. These women worked. Some of them were as young as 8, pretty much as long as you could kind of follow directions and do a task. You would be working in the mills, and then maybe they would be married off by age 15, 16. It's worth pointing out, and again, we'll kind of go into some Lowell Mill documents here, but it's worth pointing out that a lot of times there's a big fuss to be made of life expectancy at this time. Um, and the life expectancy data we have is somewhat misleading. It'll tell you that people in this time period on average live to about 40. But what that kind of adds that we maybe have to like contextualize a little bit is infant mortality was so high. So women would have children, and a lot of times those children were not making it past infancy. Children would be dead 2, 3 years old, or die in childbirth, or die in infancy. A lot of medical stuff that we've had in the last 150 years has kind of really lowered infant mortality rates, which, again, if you look at the averages, if you bring up the floor of age, right, more kids are living past age 3 today than they were in the 1840s, then you're actually adding to that average pretty easily. So in any case, these mills were not very safe, not great places to live. Again, there were children that were killed in these mills. That's why I bring in this whole like mortality rate thing. Um, the big concept, the reason that this was successful is because these were untrained employees. It's very easy if one of these children died to replace them. And that sounds kind of mean and callous, but that's how these factory owners kind of thought about it. Is these children were very replaceable. Um, if you actually like think about how a slave in the South would be treated, like certainly the stories of slaves being treated well are greatly exaggerated, but slave owners didn't want their slaves to die because that was an expensive cost to them. Contrasting it with these factories, a child dying in a factory, the factory owner at this time is not legally required to pay workman's compensation. which is what we have today. If you get injured on the job site, there was nothing that was required to pay to the families. And very often the factory owner would be able to quickly find a replacement. And so, a lot of the people working in these factories felt like they were being treated worse than slaves. Um, it's a slight kind of, you know, they're looking at their scenario and thinking it's awful. Slaves are looking at their scenario and they think it's awful. There are definitely awful parts of both systems. I'm not here to say that they had it worse than slaves, because slaves cannot leave at the end of the day, right? A lot of these Lowell mills, you would clock out and go to bed. And yeah, so slaves definitely had most of their things were worse. Um, okay, you can kind of see some numbers on here. I'm not going to go super in depth there, but like the cost of this stuff was benefited the factory owner, not so much the factory worker. This whole interchangeable parts thing was one of the vocabulary terms we put up there. What it does essentially is make everything super easy to replace. So this is like a little model of a gun. Back in the day, if you made a gun, you made it, pretty much from start to finish. Somebody would make it, and then if there was something that broke, then that person who made it would have to fix it. What interchangeable parts does is, if I have a part that breaks, I can just go to the factory or the store and replace that part. And if you think about stuff like cars today, that's incredibly what that's based off, right? If you need a spark plug, you go to AutoZone, you get a new spark plug. Um, it's hard to even contextualize and think about how things were made before interchangeable parts, but it was all handcrafted. Shoes would be made from leather, and you'd put a piece of wood on the bottom of it, and yeah, and if that wore out, then you gotta get a new shoe, or you'd have to replace it with something you had at home. So this changes a lot of industry in America. You see whole factories that are dedicated to making some of these really intricate parts. Um, as well, it maximized labor, because if I'm a worker, my job is just to make the screws that go into certain parts of this gun. Then I just have a simple task every day of making a screw. Or I might be on the end of the assembly line and putting this whole thing together, instead of making the metal, making the wood, making all the other parts of it. And so again, it's really kind of taking that master craft of somebody who would have had to make a gun from scratch and know an extremely large amount of stuff about crafting a weapon like a gun. And it's splintering that into saying, you don't need to know how to make a gun. You just need to know how to make part number 37. Right. And then I have, 50 other employees that are making the gun. So nobody is really an expert. Everyone's just kind of a replaceable robot kind of thing. Um, Eli Whitney is a big deal here, because he kind of pioneers interchangeable parts, and also introduces his interchangeable parts into something called the cotton gin, which will be a big deal. There's also this guy here, Isaac Singer. He makes the sewing machine, so a machine that stitches fabric together, makes clothing a lot easier. And then we have another guy here, Samuel Morse, and you might recognize that last name because he develops Morse code, which is used for telegraphs. Telegraphs become the text message of the day. If you think about how long it would have taken to send a letter, give it to somebody, they go on a horseback, they ride to the next town. They might deliver it to somebody who then has to deliver it to somebody else, who then delivers it to somebody else, who then delivers it to you. That takes a while. Telegraphs would send an electric pulse through a wire, and on the other end of that wire is a receiver, and that receiver would create dots and dashes in sound bite form. And so there'd be somebody on the other end of that receiver who would write down the combination that they would hear. Now, messages were not perfectly translated sometimes, but the general idea is you can send a message as quick as that electric pulse goes through the wire, which is a very quick very quick transfer of information. Um, what this does as well is kind of interesting, is like basically the Pony Express that people talk about was invented, and like the next day the telegraph was invented. And so this kind of thing, like the Pony Express, the horse and rider you can see there, is basically outdated in a day. It would be like if we went from calling someone on a phone to like FaceTime in a day. It's just a very quick technological advancement. A couple other names here is John Deere and Cyrus McCormick. John Deere does not invent the tractor. He invents and develops the steel plow. Steel was important because it was lighter, so those animals that are pulling the plow, you can see here in the picture, don't have to work as hard, which is good. And it's also more durable. So if your plow hits a rock in the ground, if it's steel, it's more likely to survive that. If it's iron, it's less likely to survive that. And then you have to get a new plow, and all of your work gets set behind. Cyrus McCormick develops a mechanical reaper, and that's to try and reap the crops, right? So it's harvesting a little bit easier. Cool. So let me try and answer these assessment questions quickly, because I know these videos can get a little long if I get a little bit wordy. Number one says, what were major developments in transportation between 1800 and 1860? We have a couple options we can go with here. So less toll roads, less turnpikes. We've got national roads. We've got canal building. The Erie Canal is a good one to mention there. And also the introduction and production of railroads. So we've got four big things there. Number two, what changes occur in the United States with the rise of industry in the early 1800s? The big thing is maybe factory work. People would get low wages, but it's increasing production of goods. And that kind of goes into the interchangeable parts thing as well, is when you have a factory full of workers, you don't have to have one master craftsman, as I mentioned earlier. Number three, what were the key inventions between 1820 and 1860 that transformed industry and agriculture? Depends how you want to stretch the word invention, because we can talk about Samuel Slater's mill. We're definitely going to mention the steam engine. We're definitely going to mention the train, the railroad. John Deere's steel plow, Cyrus McCormick's mechanical reaper, Eli Whitney's cotton gin. Those are all very big for industry and agriculture. We can also talk about the Lowell mills. Not that Lowell invented the mills, but certainly the increased presence of those mills. Number four, how might the United States have been different if transportation had not advanced during the 1800s? I mean, this is kind of open-ended and all hypothetical, but I like to think that if the United States did not increase its transportation, it's very possible on a timeline that the United States would kind of stop at the Mississippi, or maybe just on the other side of the Mississippi. We've already talked about Missouri a little bit here, but I don't think we get some of those western states. I don't think we get places like California or places like Nevada or Arizona without increased transportation. The other thing that's probably worth mentioning is the economic boom that transportation provides. So that whole thing we talked about with transporting goods up and down the Mississippi River on steam engine, like American industry just doesn't take off, right? Because if there's no goods being sold, then there's no goods. The demand for goods is low, so the production of goods is also low. Number five says, how did textile mills develop in the United States? We've had people working in textile mills or in textiles for over 100 years, but by making a mill, you're kind of concentrating a labor force. And as I mentioned, those forms of labor are really not super skilled. We typically talk about skilled labor, non-skilled labor. Someone like a doctor would be considered a skilled laborer. Somebody who works in a mill stitching together pieces of cotton for 16 hours is not looked at as skilled labor. I think there's a little bit of a bias there towards professions that maybe have advanced degrees. It's certainly a skill to not be killed in a factory at this time. So I don't I'm not going to get into semantics too much here, but saying somebody is not skilled labor is kind of a slight jab at what they do. And the last question here is, how was the development of interchangeable parts an example of the move to make work, quote, less skilled in the early 1800s? So kind of just mentioned that is, if you think about all the little parts of a car, all the little parts of a computer or a phone or whatever device you have, it doesn't take a genius to put that stuff together, and it doesn't take a genius to put all those parts or to craft all those parts. It just takes a lot of people, and so you're kind of taking the advanced amount of skill of making something and you're dividing it into 50 parts or 200 parts or whatever, however many parts you have as a that makes the whole. And so that's where it kind of makes it easier to produce these goods because nobody has to be a genius. They